All right, we're recording. On example 7, just to tie up the loose ends, we said that the point 0, negative 2 on F corresponded to the point negative 2, 0 on F inverse. We call those corresponding points, 1 comma 2 and 2 comma 1. Those are corresponding points. And these two functions, which are both 1 to 1, they're both linear. They are reflections of each other across the line y equals x. And they are inverses of each other, which means one of them undoes the other. One of them undoes the other. Okay, I'm just going to leave that at that, and we'll say we're done with example 7. Example 8 gets into a special property of inverses that I want to talk about. Okay, it says let G be the inverse of F. Find G of F. I changed the song. Yeah, it's Love Story now. Hello, Delilah. Come on in. Love Story. No. From Ryan. It's from the movie Love Story. It's called Ryan's Theme. Yeah, it's an older movie before Taylor Swift was born. Let G be the inverse of F. Now, because the notation can be cumbersome, we often do stuff like this. We just rename it. We let G be F inverse of X. No one wants to carry around that cumbersome F inverse notation, so we just give it a nickname. We'll call it G. All right? Part A says to find G. So let's go ahead and do that. We'll start working directly underneath F of X. The first step is the money step, so I'll switch to green here. And that's to interchange X and Y. Remember that? Where is Y, you ask? To interchange X and Y, I don't see a Y. Well, F of X, remember, is just a fancy way to say Y. So that becomes X now, and this becomes negative 2 cube root of Y minus 1 minus 5. Interchange X and Y. Everyone okay with that? And now we're just going to solve for Y. That's all we do. We solve for Y. Carefully, algebraically. So I'm going to have to add 5 first, so I get X plus 5 equals negative 2 cube root of Y minus 1. And now I'm going to have to isolate the cube root by dividing everything through by negative 2. So I'm going to have X plus 5 over negative 2 equals the cube root of Y minus 1. And now I need to uncube root something. How do I uncube root something? Cube it. And I'll actually show that step here because we don't see that often. Parentheses around both sides and we cube it. And now we get X plus 5 all over negative 2 quantity cubed equaling Y minus 1. And now the last step is to add 1 to both sides. Then I'll flip it around and I get Y equals X plus 5 over negative 2 quantity cubed plus 1. Now, technically, that's the inverse, but now we're going to tidy it up. We're going to rename it. What are we going to call Y? It is F inverse, but what nickname are we going to give it? G of X. I'm going to call it G of X. And then I'm actually going to split this up. I'm going to distribute the 3 factor on the exponent to both factors. I'm going to say it's X plus 5 cubed all over negative 2 cubed, which is negative 8. And now I'm going to do something else, like we did on the test when I asked you to get the equivalent transformation. I'm going to pull the negative 8 out front and call it a negative 1/8, so that it becomes the coefficient on the X plus 5 cubed. That's the prettiest way to do it, right there. Dividing by negative 8 is the same as multiplying by negative 1/8. So G of X and F of X up here are now inverses of each other. They make a perfect coding and uncoding cipher. Like if you have a friend, that's a big if, right? In my world. If you have a friend and you want to send them a secret message, you could get the letters of the alphabet laid in front of you, and you can assign a number to each one of those letters in the alphabet. You can write your message in letters and then put it into numeric code. Take each of those numbers and put it into F, and you get an output. Then you send that secret message to your friend, and they have the G of X decoder, and they will decipher your message. Before they do that, they will say, "Why did you do that, though?" They would probably say, "Why didn't you just tell me?" And then you would say, "Because it's a secret," right? It's a secret message. And after you spend all that time decoding it, guess what the message just says? No, it actually says, "I love you." And you're like, "Why couldn't you just tell me that?" Because it's a secret. Now, it doesn't matter which one you use to code. G can code and F can decode, or F can code and G can decode. These two guys are inverses of each other, okay? All right, let's look at letter B. It says to find G of F. G of F. Okay, so I'm not gonna rename this, but I'm just gonna write it here. We're gonna do G of F or GOF of X. That's the blue collar display version, isn't it? So let's write it in the blue collar, let's use the version, G of F of X. Now before we do that, let's think about this. What would you expect to get when I compose two functions back to back? If I start with X, I obviously start with X, and I apply a function to it, and then I apply the inverse function to it. What do you think we should end up with? The original. What was the original? What did I start with? I didn't start with f of x. My input is where I started. I started with what? I started with x. Yeah. So like, look, if I stand right here on the floor where there's an x, where these tiles meet, there's literally an x right here. Let's say I'm standing at x, and I apply the f function, which takes me 2 steps to y'all's left, and here I am now. And then I apply the inverse function, which takes me 2 steps back to y'all's right. Guess where I am? I'm back where I started at what? I'm back where I started at x. So I wonder if this equals x. I put a question mark over the equal sign. I wonder if it equals x. Well, let's see. Let's see if it does. We'll actually do the math. Okay, so how do we compose g of f? Well, I start with the outside function g, which is negative 1/8 times parentheses x. I'm going to put a parenthesis where x is plus 5 cubed plus 1. So that's my first step always when I'm composing. I replace x with a parentheses. X itself kind of looks formidable. It almost looks uninviting, right? Like when you see the x, which is supposed to be a placeholder for anything, it has this X look to it, like, get away from me. X, X, like you're a witch. Go on. It's not very inviting to plug something into, right? But if you replace X with an open receptacle, now it's very inviting. You almost want to just put stuff in it automatically, don't you? Yeah, like a fork into an outlet when you're young, right? It's just irresistible. Your parents tell you no, but you got to test it out for yourself. What am I going to plug in there? I'm going to plug in f of x, which happens to be, not with a highlighter, it happens to be negative 2 times the cube root of x minus 1 minus 5. That's what I'm plugging in. All right, now all I got to do is get dirty here, right? We've set it up, and now we've got to like take our gloves off and start tilling that garden soil with our bare hands, getting in there, right? Mixing it up. Algebra. Well, let's see what I'm going to do. I'm going to evaluate this using my Aunt Sally's rules. Parentheses first, so there's nothing to distribute. Those first parentheses that I wrote for the substitution, they were good for showing the substitution, but I can actually drop them. There's really nothing to distribute. And once I drop them, then notice what I could do with the 5s. What happens to the 5s? They cancel out, and I'm just left with negative 2 times the cube root of x minus 1, quantity cube plus 1. All right, now because I have two factors inside here, that's negative 2 times, I can actually cube both of them. This is the same as negative 2 cubed times the cube root of x minus 1 cubed plus 1. That's the property that says ab to the x power is a to the x, b to the x. Okay? I can give both factors the exponent. Now I can simplify. That's negative 1/8 times, what is negative 2 cubed? Negative 8. And what's the cube root of x minus 1 cubed? X minus 1. And then I got plus 1. And now I can multiply. What's negative 1/8 times negative 8? I get 1, don't I? That's 1. Anything times its reciprocal is 1. So I get 1 times x minus 1 plus 1. And of course, 1 times anything is itself. So I could drop those parentheses. And lo and behold, here, look what happens. What's the negative 1 plus 1? 0. So I'm left with x plus 0, which is x. It worked. I got x. I got x. Hey. We got what we were expecting. Let's do part C now. Let's try it the other way. What about fog of x? What about f of x, f of g of x? What would you expect to get if I composed those two things the other way? Didn't we learn in the very first example, though, Jeremy, that composition is not commutative in the elephant blanket problem? $10 off and a 10% discount, the order matters. So would you expect that G of F would equal F of G in general? No, but because they're inverses, you think the order matters? If I take 2 steps to the right and then 2 steps to the left versus 2 steps to the left and then 2 steps to the right, shouldn't I be back where I started either way? So maybe you're right, Jeremy. Maybe this should equal X again. Maybe it should equal X. I tell you what, let's figure it out. You do it on your own, I'll do it on my own, and we'll compare answers, okay? Don't peek at mine. I'm going to do it up here very quietly because I'm a little bashful. And you do it at your desk, and we'll compare answers. On your mark, get set, go. Oh, shoot. Doesn't it feel good to get the dirt under your fingernails? In there. Scratching around algebraically. I got X again. Let me walk you through the math because I see some of you are struggling in the dirt there. I plug in, and here is my function, which is down here. I plug it in, and I can drop the parentheses. I actually probably should have dropped let me add the parentheses. The original parenthesis was right here. There's actually another one right there. Yeah. So this shows the substitution. And then there's nothing to distribute outside these parentheses, so I could drop the parentheses. And when the parentheses are dropped, the 1 minus 1 will cancel to give me 0. So those are gone, and I'm just left with this piece here. And now since that's one term and those are factors, I'm taking the cube root. I could take the cube root of each factor. That's what I did right here. The -2 and the -5 are still sitting out there. So now I get the cube root of -1/8 times the cube root of x plus 5 cubed. Well, what's the cube root of -1/8? One number times itself 3 times is -1/8. -1/2, right? The cube root of a negative number is negative. So it becomes -1/2 times, and then the cube root of x plus 5 cubed is just x plus 5 minus 5. And then now you're like, ooh, what's -2 times -1/2? +1. So it's 1 times x plus 5. 1 times anything is itself. Now your 5 cancels out, and you're left with x. You're left with x. So bless you, is composition in general commutative? In general, no. But was it commutative here? Yes, okay. In fact, this is the only time composition is commutative. When the two functions we're composing are what's of each other? inverses. Let's state that right here, okay? Composition is only commutative if F and G are inverses of each other. Moreover, the result will always be, guess what? X. You start with X, you do F then G, or G then F, you're right back where you started with X every single time. But in general, composition is not commutative. $10 off and a 10% discount, those are different. All right. Comments or questions on that one? All right, that leads us to something that's down here in the box. If it's in a box, it's probably important, right? Probably so. That's why donuts come in a box usually. Donuts. Very important. This is called theorem for inverses. Two function f and g are inverses if and only if f of g of x equals x, which also equals g of f of x. Okay? The order doesn't matter. When you compose them in any order, you get the same thing, and not only do you get the same thing, you always get x. So you're not going to be told now necessarily straightforward that two functions are inverses. You might just be told we have two functions f and g such that f of g of x equals x. And you're going to be like, oh, f of g of x equals x? I start with x and I end with x? That must mean f and g are what? Inverses. Or you might be told that you're given two functions g and f such that g of f is x, which equals x. And you're like, oh, look, I start with x and I end with x. G and f must be what? They must be inverses of each other. Not only are they going to get the same thing, but they always give you x. And they're the only ones that give you x when you start with x. They undo each other, okay? That really was a phantom jingle. What's that? It has been. I think they're eavesdropping on us right now, don't you think? I like the eavesdropping sound. Do, 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 do. We're listening. Okay, good. I hope you're recording because maybe my audio gave out again too. I don't know. Someone better be recording. The government, right? Right, Siri? Right, Alexa? The squirrels. Let's look at the last example here. We'll call it example 9. Let h of x be the inverse of g of x. So h of x is some function that undoes the work of g of x. We got to find h and then use the theorem above, verify that they have the correct inverse. Give the domain for both h and g. Okay, we will. So step 1, since I'm going to have to use a lot of space here, I'm going to come over here on the far left side, and I'm just going to rewrite g of x. It's 2x minus 1 over 4x plus 3. Let's go ahead and find the domain of g while we're right here. Okay, we might as well. Can you just look at it and tell me what value is not in the domain? There's only one value that causes 0. 3/4? Negative 3/4. You would do it like this. You would say 4x plus 3 shall not, cannot equal 0. So 4x shall not equal negative 3. So x shall not equal negative 3/4. At this level, right, this honors level, you should be able to do that in your head. But if you can't, I guess there's no shame in just doing it off to the side on your workbench so that you get the right answer, right? The real shame is just in getting it wrong. That's the real shame, right? Okay, so x can be negative 3/4. Got it. Let's do the money step here, which is switching x and y. G of x is just another name for y. So it becomes x, and we get 2y minus 1 all over 4y plus 3. And now again, we're taking off our gloves and we're tilling the soil by hand. We're going to get our hands dirty. I have to solve for y. Now, how do I solve for y when I have two y's in the same equation? Algebraically, we can manipulate it. You learn how to do this in Algebra 1 and Algebra 2. The easiest way, I think, is to put x over 1 and create a proportion. When you have a proportion, you can crisscross applesauce butterfly multiply. Let's do that. You just cross multiply. So we're going to get x times 4y plus 3. That's your diagonal of 1 equals 1 times 2y minus 1. There's your other diagonal. Cross multiply. Cross multiply. Cross multiply. All right, now what are we going to do? Now we're going to expand everything. Expand it out completely. Let's distribute. So we get 4xy plus 3x equals 2y minus 1. Now we're going to collect the y terms on one side. What do I mean by that? Well, I got a term on the left that has a y in it, and I have a term on the right that has a y in it. I'm going to bring all the y terms over to the left. I'm going to bring all the y terms over to the left, and I'm going to bring everything that doesn't have a y term over to the right. And remember, when you bring a term from one side of the equation to the other, all you got to do is change its sign, yes? Just change its sign. So this becomes 4xy minus 2y equals negative 1 minus 3x. Now, the two y terms on the left side are not like terms. I can't just add them together. They have different variable parts. So how do I get one y out of two y's? Well, we're going to factor out a y. So we get y times 4x minus 2 equals, and I'm going to put the x term first over here, negative 3x minus 1. I just like the x term first, so I'm commuting those two terms. And now all we got to do is solve for y. I'm multiplying by 4x minus 2, so all I got to do is divide both sides by 4x minus 2. So I get negative 3x minus 1 all over 4x minus 2. And that's the inverse, right? So now all we got to do is rename it. It told us to take the inverse of g and call it what? H. So I'm just going to say that this must be h of x, and it's negative 3x minus 1 all over 4x minus 2. Let's go ahead and find the domain of h while we're here. The domain of h is going to be the set of all x such that x is not equal to, and let's see if we can do this one in our head. If I said 4x minus 2 equal to 0, I'd bring the 2 across, so it's positive 2. I would divide by 4, so I get 2/4, which is also known as what? 1/2. Good. That's the domain of h, the inverse. All right, so we have ourselves a pair of coders and decoders, so we can send little love letters to our friend in secret. No one has to know. All right, now it says to verify that those are inverses. They don't really look like they're inverses, do they? So let's verify by doing this little theorem right here. Let's compose them back to back. Now, do you want to do h of g of x first? That's hog. Or g of h of x? That's go. Let's do hog first. I like that. So I'm going to draw a line right here to separate our work. Let's do h of g of x. Or hog of x. Right? Hog of x. That's the display only version, and in that version we see the word hog. But in the blue collar, let's use it version, we know it's h of g of x, right? We know that we're plugging the g function into h for all of the x's. I need to take a seat for this one. Okay, so I like to start with the outside function h. Here we go. The h function down there in the bottom left is negative 3 parentheses minus 1 all over 4 parentheses minus 2. Yes, yes? And what am I plugging into those parentheses? G of x, which is 2x minus 1 all over 4x plus 3 all over 2x minus 1 all over 4x plus 3. Hot diggity donut. Look what I just created for myself. A complex fraction. We learned how to get rid of complex fractions earlier in the year. We called it destroying bunk beds. Remember that? We're going to destroy ourselves some bunk beds. The way that you do that is you multiply by a clever form of 1, that is the LCM over the LCM. So how do we destroy bunk beds? We lick them. Careful for wood splinters. Gross. Lick them over lick them. Well, what LCM are we looking at? We're looking at the least common denominator or multiple of our denominators. There's only one. It's 4x plus 3. So I'm going to multiply by, without a highlighter's help, I'm going to multiply by 4x plus 3 over 1. I'm going to give it a bunk bed. All over 4x plus 3 over 1, give it a bunk bed. And now you could draw this division line all the way across. The vinculum acts as a subfloor now between the two apartments. Because we're going to distribute the two terms, I'm going to add parentheses now around those two terms. And here we go. When I distribute to the first term, the 4x plus 3's by design will divide out. You'll see that? And I'm left with a negative 3 times the 2x minus 1. That's all I'm left with. We destroyed the bottom bunk, and then everything else fell to the ground floor. Minus, well, now it's just minus 1 times 4x plus 3. There's really no bunk beds to destroy in that second term. In the bottom, when I distribute to the first term, I destroy the bunk beds again. The 4x plus 3's divide out, and I'm left with 4 times 2x minus 1, destroyed the bottom bunk, and then distributing to the next term, it's just minus 2 times 4x plus 3. Now, if you remember from the warm-up, in the numerator, I have something that's partially factored, and in the denominator, I have something that's partially factored. Is there anything common other than a negative 1 in the top two terms? Or is there anything common other than a 2 in the bottom two terms? Is there any variable common? They both have a 2x? They actually don't even have an x that's in common. Yeah, they don't have it. They have a 2 that's in common in the bottom, but that's it. There's not an x factor or anything in there. So we're not going to factor out like we did in the warm-up. What are we going to do instead? We're just going to hit it with the little sledgehammer. We're just going to distribute all the way through. Okay? When in doubt, expand it out. So we get carefully here. Negative 6x plus 3 minus 4x minus 3 all over 8x minus 4 minus 8x minus 6. Now, what are we anticipating our answer is going to be? It should be x, right? If these are truly inverses, it should be x. Let's see. If you look now in the top, you have a positive 3 and a negative 3. Those cancel out to give you a 0 pair. So we're left with negative 10x. And in the bottom, if you notice, you have your 8x's dividing out, and you're just left with minus 4 minus 6, which is negative 10. And holy moly, smokers, what happens to your negative 10s? They divide out, leaving you x. Oh, yeah. The tulips are coming up. Or they're coming up roses. Well, then maybe that's a mixed analogy. Let's see. Hey, that was hog of x. I wonder what would happen if we did go of x, g of h of x. I wonder what would happen. What do you think we should get? We should get x, all right? Let's try it out. On your mark, get set, go. You do it on your own. Go. G of h of x. I'm going to do mine up here real quietly, and we'll compare answers at the end, okay? Yes. Uh-huh. Lick them over, lick them. Bless you. You got it? All right. This one. I thought you were calling me over. I thought that was one of those ahems. No. Any water ring on there? Oh yeah, yeah. If you get one of those plastic cups when you come in, just grab yourself a paper towel and fold it into fourths. It makes a really nice coaster. Hamburger, then hot dog. Or hot dog, then hamburger. Yeah. You have one. Well done. Yeah. Yeah. I don't like water rings. You sit down and it's like, is that snot or ectoplasm or other bodily fluids? Yeah, write it down. Write it down. Yeah, write it down. Da-da-ba. I'll get it. Mm-hmm. Okay, walking you through the composition. You got G on the outside. G is 2x minus 1 over 4x plus 3. So in place of x, I put the open receptacles first. And then in place of there, I put h of x, which is this monstrosity right here. Negative 3x minus 1 over 4x minus 2. All right, so now I have a complex fraction. The miniature denominators are 4x minus 2. So I multiply by 4x minus 2 over 4x minus 2. And I went ahead and put them both in the top bunk as well so that I can see layers. When I distribute to the first term, your 4x minus 2's divide out. And you're left with 2 times negative 3x minus 1. That's what I wrote right here. In the second term, when you distribute, you just get negative 1 times that. And I didn't distribute. I just put negative 1 times the quantity. Same thing at the bottom. When you distribute over here, your 4x minus 2's divide out. You're left with 4 times negative 3x minus 1. And then plus 3 times that. I didn't distribute. I just wrote 3 times that. So I didn't bother distributing in that second one. I'm going to do that in my next line. Okay, now all we got to do is carefully distribute. We get this. Your 2's cancel. Your negative 12x's cancel. You're left with negative 10x over negative 10. They divide out and they give you x. Nice. Nice, nice, baby. Do, 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 do. iPad, baby. Where is my iPad? Where did I put my iPad? That's the only thing about being mobile. Yes, sir, Jeremy. Yes, I thought you were going to tell me where my iPad was. All right, there it is. Yeah, I got it. What's your exit ticket? When is composition of F and G commutative? When they're inverses, yeah. When F and G, oops, with the highlighter, there I go. When F, I'll just go with the highlighter. Let's pretend like I did it on purpose. When F and G are inverses. Nothing wrong with writing with a highlighter. Or sitting on the desk when you didn't intend to. Now, when you do that composition, what will the result always be? X. Okay, good. X. Nice. We're done. We're done with 2.5 finally already. Yes, yeah, let's go ahead and talk about what's coming up here. So Tuesday, I'm going to switch from highlighter now on purpose. On Tuesday, homework section 2.5 is due at 9 a.m. And on Tuesday, we're going to do a practice test / review. Wednesday is the PSAT. I will not see y'all. Today and Tuesday in advisory, there's stay put place. Today we're staying put in advisory. So make sure we get the Blue Book app figured out and that everybody knows where they're supposed to go next Wednesday for the PSAT. You should have gotten a little paper that had your room number on it. You're supposed to take a picture of it. Make sure today in your advisory, you don't leave until you are finished registering in your Blue Book app and you know what room you're going to on Wednesday. So I won't see y'all on Wednesday. What's that? You're supposed to do that today. Our teacher made us do that like entire process Right, but just in case, we're also going over it today and on Tuesday. Today and Tuesday are both stay in places for advisory to make sure that everyone is squared away. It's that important. So I won't see y'all Wednesday, but Thursday I will see y'all. Y'all will be coming in all filled with alacrity and optimism because that's when we're having our test on section 2.1 to section 2.5. So really, it's only one additional section from our previous exam, right? One extra section, and that's what we just did. So will you see some of the same questions on the test that you saw on the last test? Oh, for sure, right? For sure. So make sure that you know how to you learn from all your mistakes on the previous exam. And then on Friday, next Friday, we're going to go over the exam in class. You'll have them back already because if you need to retest, that's the last day of the 9 weeks. You either retest Friday after school or Monday before school for the retest after we go over it. Okay? We'll go over it in class on Friday, and then you either retest Friday afternoon, I'll stay here, or Monday morning because my grades are due this Monday morning at 10 a.m. All right? Now, you can avoid this scenario altogether by doing what? Not failing the test on Thursday, right? Or, yeah, just pass the freaking test. Just prepare and pass. Prepare and pass, and then you just be like, I don't even have to come back in. I got it, right? I got it. And then the following Monday, we'll start chapter 3. We'll do 3.1. And then Tuesday, we'll probably be doing 3.1 again. Wednesday's probably going to be 3.1. And quite honestly, Thursday's probably going to be 3.1 again as well. But Friday, we'll be into 3.2, which means the following Monday, we'll still be in 3.2. And then that Tuesday, we'll be in 3.2. And I don't really plan that far in advance. I'm pretty good if I can get the day planned in advance. So just to know that this is what the week is going to look like, we're in good shape, okay? All right, I think you got 5 minutes, right? So you can either work on your worksheet or you can kind of get in a good vibe for next period. And I hope this recorded all the way through. Please, yes, it did.